Okay, so I'd like to thank Gabe for bringing number 16 and 13.4 into my life. Thanks, buddy. I guess I shouldn't be making fun since I'm the jackass who assigned this thing to begin with. So we have the sum from j is 1 to infinity of 7 times the quantity 0.1 to the j plus 0.2 to the j plus 2. I'm supposed to break this up somehow and find the sum. Okay, so what is the thing I know? And you might want to put this in your head. So this is the geometric sum formula, right? Which is the sum from n equals what to infinity of r to the n is, I just remember 1 over 1 minus r. Where does this thing start again? 0? Okay, so this is a formula that I have. Now, over there, I have things that look vaguely like this. You guys see the parts that look vaguely like this?
Yeah.
Like, that guy looks pretty similar, right? This guy looks pretty similar. Okay, but there's some stuff in the way, right? So here's what I'm going to do. I'm going to say, okay, first things first, I'm going to factor out a 7. Why can I factor out a 7?
Because it's multiplied by the quantity of that?
Yeah, it's multiplied by everything in there, which means that if I wrote this sum down, right, there'd be a 7 in each term. So I'm going to take a 7 out. So I'm going to get 7. And then I'm going to have the sum from j is 1 to infinity of, let's see, 0.1's inconvenient. I'm going to write that as a fraction. Okay? So I've got a 10th to the j plus, what's 0.2?
2 over 10.
2 over 10, which is
1/5.
1 over 5. So I got 1 over 5 to the j plus 2. You guys all good with this? And really, I should maybe put in giant parens, right? Okay, 7 times all of that stuff. Cool. Okay. Now I'm going to do this thing that's probably cheating. Okay. I'm going to break this sum into 2 pieces. Cool? Be a little concerned about this. This step sometimes makes things act a little strangely. So I'm going to get 7 times, what do I mean break this sum?
Just the first part and maybe add the second part.
Perfect. So I'm going to write down the sum from j is 1 to infinity of 1/10 to the j, right? That's just the first sum. And then I'm going to add to that the sum from j is 1 to infinity of 1 over 5 to the j plus 2. Guys with me? Okay, cool. Good to go? Okay, now I might think to myself, what's the difference between this first sum here and my sum formula? Yeah, this one starts at 1, this one starts at 0.
Be 1/10 minus 1. No. 1 over.
1 over 1 minus r minus 1.
Yeah, so this is the same thing as this, except that this guy has 1 more to it, right? So I'm going to subtract 1 from both sides of this equation, and I'll get the sum from n is 1 to infinity of r to the n is 1 over 1 minus r minus 1. You guys cool with that? So I'm going to cram that in there. Pretty good? So that's going to get me to, so this is going to be a going to call that formula star 1. And that's going to get me to 7 times, wait, what was R in there? A 10, right? So I got 1 over 1 minus a 10th minus 1. That's that first bit. And then I got plus, and I'm not dealing with that one yet. So j is 1 to infinity of 1/5 to the j plus 2. Cool? Yeah.
Where does the J go?
Where does the j go? Oh, good question. The j is just a sum index, right? So I just said, well, no, j is 1 here. Or j is n here, rather. It's just keeping track of how you're moving forward through the sum, right? And so it moves by steps of increment 1. N's move by step of increment 1, so they may as well do the same thing. As differentiated from this j over here. This j over here has a plus 2 on it, so I can't straight up apply the formula. You guys see that? So what do you want to do? You can pick. You get to either modify the formula or make a new one. I don't care what you do. What do you guys want to try? Okay, so if you want to modify it, you can think to yourself, okay, if j is 1, what does this thing start at?
3.
Yeah, this thing really starts at 3, right? So I'm just going to cross this out. I'm going to put an n up here to stand for the new sum index. And I'm going to cross out the condition j is 1 and just start n at 3.
So would you have to subtract 3 off of that one then?
Okay, yeah, so now to get this one to look like my original, right? Now I've got this star 1 that starts at n is 1. Right? So really I'm kind of thinking this guy looks like r plus r squared plus r cubed plus da da da, right? And this guy starts at 1/5 cubed plus 1/5 to the 4th plus da da da, right? So I need to get rid of those two. Those are extra, right? But I can do this same trick where I just subtract them to the other side. You guys see that? So if I subtract here r and subtract r squared, I'd get a new formula that says the sum from n is 3 to infinity of r to the n is 1 over 1 minus r minus 1 minus r squared. That's cool. And then I can use that over here. Oh, whoops, I did this. So that should be from n is 3, and here should be something n. And then we'll use this star, and maybe I should call that thing 3. Right, and then this is star 3. That's the sum formula modified for 3. And so I should get all told here 7 times 1 over 1 minus a 10th minus 1 plus, and then I need 1 over what? 1 minus 1/5 minus a 5th minus a 25th. Does all see that? Has that been magic? Oh, shit. I forgot one.
What was the goal of this question again?
Let's to sum this thing. So I was supposed to find the sum, I think. Is that what I was supposed to do? That's what I'm doing. I'm going to assume that's what I was supposed to do. Find the sum. Yeah. There. Cool. So then, yeah, that simplified is the sum here. Cool. Do you guys want to simplify that, or do you want to just call it a day? I hope it's pretty algebra-y, right? So I've got 7 times, let's see, 1 minus a 10th is
9/10.
9/10, so that'd be 10/9 once it's flipped over, minus 1 plus, let's see, 1 minus a fifth is
Well, it's
4/5, so that should be 5/4 minus 1 minus a fifth minus a 25th. And then we just have to go find ourselves a common bottom for all of that jazz, right?
Or we can do -2.
Okay, good. You can dump one of the minus ones and make that a minus 2.
We have 5/25.
Yeah, okay, so then we can start replacing, right? So we've got a fifth is 5/25, and I've got minus 5/25 minus 1/25 is
No, 6/25.
minus 6/25.
Oh.
So I could dump that into minus 6/25. And then, yeah, I'm gonna have to find some common bottoms here eventually.
It's not gonna happen.
So I think the common bottom there is gonna be,
100 for the 4 improvement.
yeah, 100 here. And then there's no common factors between 100 and 9, so the common bottom's 900.
Sweet.
So you're gonna get some 900s.
Small.
Cool. I would personally, like, if I was doing this, I would probably not be modifying my sum formula. I would just be developing a new one every time I needed to use it by using that trick. You can do whatever, basically, but I think this is more prone to error than the other way. The other way is just trying to get the sum formula by calling, so you'd take this thing, right, your sum from 1 to infinity of 1/10 to the j, right? And you'd write it out, you'd call the sum something, you'd multiply it through by -1/10, add them up, collapse. It's a little more work, but it's a little less prone to stupid errors, like dropping that 1 out. Cool?